So guys. On this first one, what's the degrees of freedom? 5. Which column do I want? Which column do I want? First one. 1% in 2 tails, right? Because there's 99% inside. So the t-score, I stop at 5, and I get 4.032. So I think most of you guys got that I saw. This one, what's the degrees of freedom? 100. 90% confidence, so what percentage is outside in the 2 tails? 10%. And degrees of freedom is 100, so I stop at 100 and I get 1.660. Is that right? Is that what you guys got? Okay. You're all like, dude, you know if it's right. Is that what you guys know? This is the neat one. The general thing in statistics is if there's a piece of it that you're not sure about, you always have to make things worse for yourself to cover for that, to be more honest. So I don't have 92 degrees of freedom. So I got to use 90. I got to make the t-score bigger to cover my ass for not knowing what the right t-score is. If I was using technology, it would tell me exactly what the t-score was, but then you guys wouldn't learn shit. So that's why I don't do that. When you get out in the real world, you got to calculate the t-score exactly. You're going to have software and all that crap to do it for you. Whoop-de-doo. Okay, sorry. I go off on these little preaching things. I'm sorry. So T, in this case, I want to use degrees of freedom. I got to use 90 because 92 is not on here. And which column am I looking at for 98% confidence? Yeah, this one for 2%. All the way down here to 100. 2.364? I'm sorry, not 100. 90, 2.368. Bam. Somebody was asking me, like, if degrees of freedom was right in the middle of 2, then you can round it. That's the same kind of thing with the z-score chart in a way. But in general, if you don't have the degrees of freedom, then you have to make things worse for yourself. You make the t-score bigger, which means you go to the next lower degrees of freedom that you have. Okay. Now watch this. This is kind of funny. On your formula sheets for the next test, you are going to have these formulas. And you're going to have the p-hat one. Who gives a shit about that one right now? Right? And you have a few more formulas, of course. Do you see how this is a note? These two make a note. When do I use Z? When I know sigma. When do I use T? When I know S. Now be careful. When do I know I can do anything? I've got to be working with a normal. So that's the first thing you check. If it's not normal, who gives a shit what standard deviation you know? Can't do anything. Right? And then the second thing you check is which standard. I always get somebody that says, we use z-scores because we know the standard deviation. No, that doesn't make any sense. Which standard deviation do you know? If it's the population one, z-scores. If it's the sample one, t-scores. So the very first problem, first thing we check is it normal? Is it normal? Sample size ain't big enough. But it says normal. Yeah. So the only time I need n greater than 30 is if it doesn't already say it's normal. It says it's normal, so I can have whatever sample size I want. And which standard deviation do we know? We know sigma, so I can use z-scores. So of course I'm going to use the t-score chart to look that up. And this is always, I don't care how many times I say it, somebody's always like, what the shit? Z-scores live on the t-score chart at the bottom, and that ties in to the idea of t-scores. If my sample's large, I don't need them. So therefore z-scores live at the bottom. So which column am I going to look in? For 90%, which column? 10%. Yeah, this one. 10% outside and 2 tails. And I just go all the way down. If I go all the way down, I get a z-score. 1.645. Kabam. What about B? It says it's not normal. Shit. No, it's not. It says it's not normal.
N is greater than 30.
But N is bigger than 30. So it is normal enough. You guys understand what I'm saying? It's the first thing you look for, because if it isn't normal, if I don't say it's normal and the sample size isn't big enough, you don't have to do anything. So how often am I going to do that for you? Not, right? So if you think you have a situation on the test where you technically can't do it, you still do. Maybe give me a little note. I don't think we should be able to do this, but here it is. Because if you leave it all blank and you miss something, oh shit. You understand how that would be really evil? If I'm like, a few people are going to notice they don't have to do this, and the rest of them are going to be wasting time. That would be so... I'm not that evil yet. Give me another 10 years, maybe. Then I'll be over all you guys. No, sir. So how do I get... Now, which one? So I know I can do something. And like you just said, I have to use T, because I don't know sigma. I only know S. So to use T, I got to figure out what first? That's right, kids. Degrees of freedom. What's that? 38. Good. One less than the sample size. So could they have made this stupid chart with N here? Yeah. They didn't. Too bad.
Are there any circumstances under which degrees of freedom does not equal N minus 1?
Oh, yes. Definitely. Later this semester, we'll be working with 2 samples instead of 1. And then it might make sense that in some cases you could use N1 plus N2 minus 2. It's like N minus 1 twice. I don't know if that makes any sense. Anyway, short answer to your question is, yeah, it's not always that. Okay. So degrees of freedom 38, 98% confidence. So which column do I look at? This one, because there's 2% outside and 2 tails. And I just stop at 38. Yeah, 2.429. Is that right? Is that what you guys got? I don't trust my eyeballs. Did I tell you got like one working eyeball? Isn't that neat? I might as well tell you because I started to. Because somebody came up the other day and I felt like I should say something because they stood right here and I didn't realize they were there because I can't see this way. But I have about, I'd say like, well, maybe it's up to 50% sight, 40-something%. Like last year, at the beginning of last year, this eyeball just kind of like went. Have you ever like smushed your eyeball on something and took it away and it takes a while for it to clear up? Do you know what I'm talking about? That's what this one looks like permanently, right? So that's neat. So if you come up this side of me, I might not even see you coming, right? And sometimes my depth perception has gotten way better. It was so sad. I tried to play basketball, for example, and I tried too soon, I think. And that was just, I thought maybe I'd be better because I normally suck at it, but I got even worse. But my depth perception is much better. But just in case you guys come up on this side of me and I'm like not doing anything, just go, yeah. All right, sorry. Anyway. So what about part C? Can we do it? Nope, why not? It's not normal and the sample size doesn't save us. So that one we technically can't do anything. And what about part D? Part D is kind of like the opposite of that. It's like overly normal. It's like, all right, dude. Population was already normal and sample size is big enough too. But, so it's normal. But we only know S. Therefore, we have to use a t-score. I like it. Okay, maybe. So I know I can use a t-score. What's the degrees of freedom? 60. So degrees of freedom are 60, and then which column am I looking at? Yeah, 99% means 1% and 2 tails, so I go down and I stop at 60 and I get 2.660. That's a beautiful analogy to the 1.660 we got up here. Ha. Whew. Okay, the last problem for today, because I'm just going to get nothing but loopier if I keep going. All right. The formula does not really change. It's X bar plus or minus score times standard deviation divided by square root of n. I sometimes reference Z and T as if they're the same thing because really, conceptually, they are. T scores are Z scores that are just a little bigger to cover us for when we don't know something. None of that makes sense, I'm sorry. So what's the formula I'm going to use for number 3? Do I know that it's normal? Yes, so that means I could do something. Do I give you the population standard deviation? Do I give you any standard deviation? No, because I'm evil. But how are you going to find it? Yeah, 1 var stats. And of course, which one do you have to use? Sigma or S? I always get somebody who says, but the calculator told me sigma, so I used the Z-score, Jeff. What are we putting in? What is that? It's the sample. So the calculator gives us both because it's dumb. It's a dumb little thing, right? We are the humans. We have to know which one. Oh, it's a sample I put in. I got to use S. You don't get to choose. So go ahead, put that into list 1. See if you can calculate X bar and S. And then we'll worry about what T-score to use. Oh, let me do it with you guys. By the way, there's like a 5% chance that this eye will go too. That's always interesting to me. As I'm driving down the road. I admit it now. Yeah, it's good that I'm optimistic. By the way, I did just get a new driver's license, so I actually had to do a drive, which really, I'm 47, so the last time I had to do that was forever ago. So she's sitting there, now take a left here. You look both, I'm like, this is crazy. So I passed. So according to the state, I'm safe to be on the roads. So if you see me on the road, just let me go ahead. I wouldn't blame you. All right. What do you guys? Anybody getting the stats for this? Anybody got X bar yet?
18.6.
Yeah, 18.1.
Repeating.
Yeah, so like 18.17. I would tell you how many places around on the testers. Yeah, normally I don't want around too much, but this is fine. And then what's your standard deviation? Somebody having trouble getting that? So stat, you got your data in list 1, right? Then where do I go? Stat, calc, 1 var stats, because I only have 1 column, that's 1 variable. List 1, and there they all are. Okay. So what's my standard deviation? 5.879. Beautiful. Can't use that one. Too bad. 5.879. So how do I find my T-score? What's my degrees of freedom? Good. And what's my confidence level? I want 98%. And I might as well tell you this right now. There's a symbol we use for the area in the tails or tail of a situation. So a confidence interval has 2 tails. What area is in the tails of this interval? What area is in the tails? What area is inside? What area is outside? All right, so 2% in the tails. The symbol we use for that is the Greek letter alpha, the little fish dude. So alpha in this case would be 0.02. So right here, these are all alpha values. Right? They're dominant. No. They're the area and the tail. I love it because it's a symbol that looks like a fish that has a tail, and it's the area A of the tail, fish with the tail. Anyway, sorry. I'll stop. So, you want to look at this one. Degrees of freedom 5, I get 3.365. And now you got everything you need for the formula. You can throw all the stuff into the formula. X bar, give or take, that business, and I can just throw it all in there. So this is what I said earlier. You might have to calculate more stuff. You might have to do one bar stats. It doesn't matter where they come from. You know where to put them in the equation. Is everybody with me on this? How are you guys doing? No? Yes? Makes me worried when nobody says either yes or no. Don't want to let you know, man. You'll find out later. Okay. So 18.17, give or take 3.365 of these. Where'd it go? What's N6? There it is. So that came from the confidence level. This one we calculated, this one we calculated, and this was, of course, 6 data points. One mistake people make is they put the degrees of freedom here. Right? Just, no, don't do that. It's got to be N here. I know, nobody wants to ask a question because you're like, this is the last problem, let's get out of here. 3.365, shit, 3.365 times, whoops, got it. Enter. So I get that as my error. 8.076. So let's see, store that in X, 18.17 minus X, 18.17 plus X. So my interval I get is 10.09 up to 26.25. So we are 98% confident that the interval 10.09 to 26.25 contains the true mean of this. That is so enough for today. So I'll see you guys tomorrow. We just did all at chapter 8, by the way, just in case you're not clear on that.